All right, chapter 3, and we're going to be doing sections 3, 4, and 3, 5 in this video for our review. So, number 18, determine which lines, if any, must be parallel. Explain your reasoning. On this one, we have X and Y. These two lines are going to be parallel. Why? Well, since X and Y are both parallel to the same line Z, they must be parallel to each other. That was one of our theorems from this chapter. On number 19, we cannot actually say that any of these are parallel. I could definitely draw this figure so that we had none of these lines parallel. The fact that W and Y are perpendicular and X and Z are perpendicular are completely separate from each other. So there are no lines in that one that we can actually say are parallel. On number 20, there's a lot going on here. So we have actually all three of these lines we can say are parallel, as well as both of these lines are parallel. So L, M, and N are parallel, A and B are parallel. Now for the explanation. So we have, let me get rid of the circles for a second. We have both L and N are perpendicular to line B because we gave those symbols there. All right. So we know that those two are parallel. So L and N are parallel. Then we know that N and M are perpendicular to A. Since they are both perpendicular to A, then they are parallel. And if M is parallel to N and L is parallel to N, then M and L must also be parallel using our theorems. And then finally, the same two that I circled in orange here, A, oh, sorry, not in orange. Let's do a different color. Here we have N, N, yeah, this line. A is perpendicular to N. B is also perpendicular to N. So since A and B are both perpendicular to N, then they are parallel with each other as well. So again, lots going on in that figure. On 21, here we can see that A and B are both perpendicular to the same line N, so they must be parallel to each other. Now, we only have one mark down here on C, and it's not on the same line as either of these other two lines. So we can't say for sure C is parallel. So we know A and B are parallel. Now, what about M and N? Well, M and N, unfortunately, yes, we have perpendicular marks, but we don't have them on the same line. So we cannot say that M and N for sure are parallel either. Again, I could take M and C and I could tilt them sideways and still have that same mark, and they would not even look parallel. So that one does not work. All right, going down to 22, the proof. Let's see. All right, so this proof can be done in many different ways. There is a very short way that you can do this though. So I'm going to try and keep it simple. I'm going to type this out. Now, the first thing that we have is our given statement. So angle 1 is congruent to angle 2, and H is perpendicular to K. So let's see, how am I going to do that? This might not look perfect on there, but I'm going to say angle 1. I know that's not really the angle symbol, is congruent. I'll change this to a congruent symbol in a minute. To angle 2. And H is perpendicular. No, that doesn't work. I'll change that to a perpendicular symbol in a minute. Perpendicular to K. All right. Y given. So let's go ahead and fix that a little bit. So we have, this was our perpendicular symbol. This was our congruent symbol. All right, close enough. So we have that. Now, after that given statement, like I said, there's a couple different ways that you can go from here. Easiest thing to do, though, is the fact that we have these two lines, K and G, are actually going to be perpendicular to each other. Now, you could go through all the separate reasons because we had a theorem that we proved already. If we have two lines that form a linear pair, like 1 and 2, and that linear pair is congruent like this, that means that they must then be 90. If they're 90, they're right angles. If they're right angles, that means that they are intersecting so that they are perpendicular. So we had that theorem. We can use that theorem now in this proof. So we can say that G is perpendicular to K. And again, I'll have to write in that symbol here in a minute. For now, I'll just put a L there to hold its place. And how are we able to say that? Well, that was linear pair, perpendicular theorem. Oops, let's get that all on the same side. All right. Again, let's move this. So we have, it looks close enough to our perpendicular symbol. All right. Again, I don't have my pen with me today, so it'll have to do. Then from there, we can say if those two are perpendicular, and we know in the first one, these two are perpendicular. Well, notice we have K in both of those statements. Since we have K in both of those statements, since H and G are both perpendicular to K, then that means the lines must be parallel. So we can say that G is parallel to H and Y because of lines perpendicular to a transversal theorem. So again, we did this in 3 steps, so it's not a very long proof. Now, again, if you don't know these 2 theorems well, we could have used probably 3 or 4 more steps per theorem there. So we could have made this into probably 10 steps almost. But again, if you know your theorems, that's all we had to say. All right, moving on to the next one. So let's clear this off, and we're going to move down to 3.5. Let's make this a little bit bigger. All right, for these, so you find the coordinates of point P along the directed line segment AB so that AP to PB is the given ratio. All right. I'm trying to think of how I can write this out since I don't have my pen. All right, first, we need to take a look at these 2 values. We have 1 and 3. So in all, we are going to have 5 parts. We're going to go 1 out of those 5 parts down the line. All right. Sorry, 1 out of, I said 5, I meant 4. Let me try that again. 4. 1 out of 4 parts, not 5. I can't get rid of that blue box. There we are. All right, sorry. 1 out of 4 parts, because 1 plus 3 is 4, so 1 out of 4 parts. Now, we do need to do our, we could do distance formula. We could draw this on a graph. We could count the difference, but we're going from A x value to B's x value. So really all we're doing is going -3 to 5. So I'm going to say -3 minus 5, which gives us a total of -8. Now, that -8, that's an overall distance. If we went the other way, it'd be +8. So we can call this +8. So now, once we know that, well, +8 times 1/4 is going to give us, well, 8 times 1 is 8, divided by 4 is 2. So we are moving 2 units on the x value. Well, what do we do then? We take that and we add it to our original x. So our original x was at -3. We're going to go from -3. We're going to add 2. And that gives us a value of -1. So that's our new x coordinate. So our x coordinate is at -1. Now we're going to do the same thing, but for the y's. So we need to figure out how far we moved for the y's. Well, we went from 2 to 5. So that's a difference of 3 spaces. Then after that, we're taking that 3 and multiplying it by that 1/4. And that's going to give us a difference of 3/4. We can't really reduce that. So I'm moving 3/4 of a unit down the line. So from from 2, so 2 plus that 3/4, that's going to give us 2.75. So we have our x value is going to be at -1. Our y value is at 2.75. And again, that's our point. That's going to separate this segment into that ratio of 1 to 3. Now we can do the same thing for the next one. So we're going to take, for 24, we have 3 to 2. So on this one, 3 plus 2 is 5. We're going 3 out of 5 units down the line. So that's the fraction I'm going to be using. Then the same thing as we did before for our x values, find how far we're moving. So from -4 to, from +4, or -2 to +4. So subtract the difference. If I subtract a negative, that actually becomes adding a positive. So that's the same as saying 4 plus 2, which is actually going to be a total distance of 6. So I know I'm going 6 units down the x-axis. From there, we're going to go and take that value and multiply by 3/5. So 6 times 3/5 gives us, let's see, 8. That's going to be 18/5. We can't really reduce that. This is not a very nice problem. If we want to write that as a decimal, we could also write this as a decimal. That might be better for this one. That'd be 5.6. So then we're add that onto our first point. So we have -2 plus 5.6. So that'll get us to a new mark of 3.6. So that's our x value. All right, same thing for y's. So then for y's, we have from 4 to -3. So this one, we're actually going a negative direction. So -4 gives us -7. So no different than the other ones. We're taking that -7, we're multiplying it by that 3/5, which gives us -21/5. We want to write that as a decimal instead. -21 divided by 5 is going to give us -4.2. So we're going to take the value that we started from, that 4, and we're going to add to that -4.2, which brings us to a value of -0.2, or -0.2. So our new point is going to be at 3.6 and -0.2. Now, the good news is we don't have to do this one on the test. So I am not putting any type of directed line segment, proportion, partitioning, whatever you want to call this. It's not going to be on the test. All right, that one is not going to be on there. Now, will you see it on an exam or on the AOC? Yeah, it most likely will. They usually have at least one of those questions, but again, won't be on this test. Now, for the next part, write an equation of a line passing through point A that is parallel and perpendicular to the given line. So they want both the parallel and perpendicular lines here. So first thing we're going to do is we're going to take our equation and identify what our current slope is. So our current slope in this equation is actually just 1. So m equals 1. Great. So then for our parallel line, our slope will also be that same value. So our slope will be positive 1. Now, we need to write it in an equation. So we have point slope form would be the one to plug in here. Y minus the y1 value of -4 equal to the slope 1 times x minus the x1 value of 3. Then we have to simplify here a little bit. So we have y minus a negative is really plus a positive. So that's y plus 4. And then we have on the other side 1 being distributed. So we have x minus 3. We need to get 4 over to the other side. So we're going to subtract 4. So we're going to have y equals x minus 7. And that's going to be for our parallel line. Oops, that's supposed to be an x minus 7. Now, for a perpendicular line, we do kind of the same thing, except for our slope, it's going to be the opposite reciprocal. Now, if you flip 1, it's still going to be a 1, but it's going to be a negative as well. So our slope here will be a -1. Again, plug it into the same equation though. So we'll plug in that 4. We're going to end up with y plus 4 again. Equals, this time our slope is negative, so -1, parentheses, x minus 3. Distribute the negative this time, so it's going to be a little bit different for our answer. We have y plus 4 equals -1x plus 3, because a negative and negative makes a positive when multiplying. Then we bring the 4 over, so we're going to subtract it. So we're going to y equals -1x minus 1. And that'll be our final equation. All right, on the next one, same thing. Again, identify what our slope is first. Our slope on the original equation is 1/7. So we're going to have to do the same thing that we did on the last one, parallel and perpendicular. So first doing our parallel, our slope is going to be the same. So m equals 1/7. Then we have y minus our y value this time is 5 for y1 equals our slope of 1/7 times x minus x1 this time is -1. So we have the exact same thing, but we're going to have, I'm going to change that to a positive. Let me do that first so that we can see this better. All right, so now y minus 5 is equal to 1/7 gets distributed, so that's 1/7 x plus 1/7. Then we need to get the 5 over to the other side, so we're going to subtract it. This one does not work out very nicely. I'm not going to give you any fractions like this on the test. So we still have the 1/7 x. And then we're adding 5 to that. So we're going to do 5 times 7 plus 1. 5 times 7 is 35. Plus 1 is 36. So 36/7. Or if you want to do it as a decimal, you could do it as a decimal. But that would be our answer. All right. For a perpendicular, it doesn't get any nicer. Let's see this. Trying to see if there is. Some of these don't match up with the answer keys and stuff, so I'm just trying to see where we're at. So yeah, they gave a slightly different problem in the answer key. All right, so they did not have this one in the answer key, apparently. At least I can't find it anywhere in there. So perpendicular. We're going to flip it. So we have m equals -7. And that's going to be our slope this time. So this one might be a little bit easier since we don't have to deal with the fraction. We have y minus 5 equals -7 times parentheses x. Again, we know this is going to be +1 because minus a negative. Then we can distribute the -7. So y minus 5 equals -7x minus 7. Again, that's after you distributed it. And then we can bring the 5 over by adding. So y equals -7x plus 2. Nope, sorry, minus 2. Minus 2. And that'll be our new equation. So in the answer key for this one, I'm just looking through. It doesn't quite match up perfectly. I think they made some changes in the book and didn't make the changes online or on the answer key. So like 26 was actually 29 in the answer key. However, they didn't do both parts. They didn't ask for both parallel and perpendicular. They only asked for perpendicular. So we only have this one answer. We don't have both the answers. All right. Then on 27, it said find the distance from point A to the given line. We're not doing this one. We're not doing anything like this on the actual test. Again, 25 and 26, yes, we're going to do something like that. But 27 and 28, we're not going to do. And that's going to take several steps. And since I don't have my pen with me, I'm not going to run through all those steps right now. But first, we would have to find our equation for a line that's perpendicular. Once we find our equation for a line that's perpendicular, then we would be doing our, we'd have two equations, our original and our new one. We'd have to do a system to solve. So we'd do either elimination method or substitution method, find a point that they shared in common. Once you found the point, you're gonna plug it into the distance formula, the original point and the new point, and then you'll have your answer. Again, it's a lot of work. You're not gonna see it on the test at all. All right, so we're gonna stop this video. That's it for the review. Now, the last video will cover the practice test.